Okay, so for this is from Hard Bucket, and here what we have to do. It's a two-dimensional grid, which there are four types of squares. So one representing the starting. So let's take an example of this. So which here it is saying one is the starting point, two is the ending point, and 0 represents the empty squares, and -1 represents the obstacle that we cannot walk over here. So what we need to do, we need to give them and the one thing is, the actually we need to return the number of 4 directional walks from starting square to the ending square. So we need to return the answer of how we are approaching. We need to reach 2, and how we need to reach 2, we need to reach by 4 directional walks. Like from here we can go right, down, and if we are here also, if this is our cell, then here we can move up, left, right, down. So we need to give the answer of how we are reaching to that particular destination, which is 2. And one thing more, I think we need to traverse all the zeros over here. So it's saying return the number of 4 directional walks from the starting square to the ending square that walk over every non-obstacle square exactly once. So if we are traversing by one path, then we cannot traverse that particular cell again to reach to the destination.
And I believe, like, help me understand if I'm getting this correctly. The problem statement is saying that we have to cover all the zeros.
Yes.
We cannot like
Yes.
leave any zero.
Yeah, we should. That's one of the point. Otherwise we would reach like from here, starting from 1, going down, we'll be reaching directly, and then going right, we'll be reaching directly to 2. But that's they are saying we need to cover all the zeros over here. So that's one trick. Whenever you are taking a path, you need to check. You should travel all the zeros, and you should not repeat the 0 while you are traversing that particular path. So for example, over here they are saying they are going to 0 0. I think I put like this. They are saying they are 0 0 0 1. I think they are going like this. Then I think
I believe like it's the first row starting from 1, traverse all,
yeah.
and then down,
Then down, then
to the left, and then
and
down, and then
and
to the 2.
right.
And then the
Yeah.
other thing is
Down,
up, right,
then up,
then right, then right,
right.
all the way to the end.
Yes, all the way to the
And
end, and then
down,
going down, and then
yes,
coming
yes,
back, and
yes.
then reaching to. Yeah. So these are the two approaches, which they are saying. And this one, okay, this is another. So
let's talk about the first problem only, like the
okay.
first example, and then we can go to the second.
Yeah.
So
So
what
any
kind of
approach,
logic we can apply here?
yeah, seems like we are going the depth of all the paths. I think depth for search would works best over here.
So there are two options, okay, BFS and DFS.
Mm-hmm.
Will BFS work?
BFS might not work because we'll visit all neighboring cells and then go ahead. And then we can step, if we want to step over it for the one path, it will take us already restricted.
That's what I'm thinking, but if anyone has any things, Because BFS is like not a solution here. I'm not sure like BFS will work or not.
But yeah, even I want to see like if BFS can work.
Yeah, even for DFS, like when we are doing the DFS, we have to make sure that all the zeros are covered before we reach 2. Okay,
Yes.
so for this problem statement, 1 can be anywhere. Okay, and 2
Yeah.
can be anywhere.
Yes. One can be anywhere and two also can be anywhere.
So like, do we need to do the first pass to figure out where the 1
Where is
is?
the one? Yeah, where is the one or where is the two? Or just need to check where is the one.
I don't think
Yeah,
like you have to like
okay.
figure out the 2. Okay, but do we need to count like how many zeros are there? Like, is that a requirement?
Yeah, we need to find out where if all the zeros are covered. So
That's
it
not
should
the
be either count.
requirement, but it will help to actually make sure that we covered all the zeros.
Right. So I think like maybe we have to do like a scan first of this grid.
All the zeros. Like walk over every non-obstacle square exactly once. So that's one of the requirement there.
Yeah. So we have to do like one pass of the whole grid and then figure out how many um, zeros are there and what's the starting point of the 1. Okay. And then from that 1, we have to do the DFS to figure out how many ways like maybe we can reach 2, making sure the length of the path by which we can reach 2 from 1 should include all the zeros. So yeah.
So we need to take one visited also, like to make that we should not traverse that particular cell again.
Yes.
Uh,
And we might need also something of backtracking to say, okay, if whatever.
Yeah, that where I was teaching that. Yeah, so we need to make them again as it is also, because we need to traverse them again if we have another path. So we need to do a backtracking.
True. Yep.
Okay. So is this one approach? So
I think so. Is there a possibility that like we can traverse the same path again? So let's say like we are like in this example we are starting with 1. Okay. And while we are doing the DFS, we go all the way to the right, down, then all the way to the left, down, and then reach 2. Okay. And then so this is like where we started, like the 0 on the right of the 1. Okay. So it will give us like one path. Now while backtracking, we have to again mark all the we have to reset it, like we have to again mark, okay, like we haven't gone through those, because we have to like redo the visited metrics, and then maybe we start with the again second neighbor, which is 0 at the bottom, like at the bottom of like just below the 1. Okay. Yep. Yeah, I guess like that should work.
And then the other zero could be used again.
over here, so this is the same question. I think the only difference is example. This only difference is over here. So my question is, how it is more than 2 paths? Because over here they are going to this direction and down.
So in this case, like you can go all the way to the right, then 1 down, all the way to the left,
and then
make a Z, and then the other one that you're telling, like go all the way to the down, then right all the way up, and then right,
extreme right, then going down, then coming back, then going down, and then reaching over here.
And
one is zigzag like this, I suppose. No, this. So, okay, so I got it. Like for each particular cell, they are going traversing all the 4 directions and checking if it is not traversed, then we will be traversing that path.
Hmm. And if like cell is already in one path, we don't want to visit it again. Like if it is coming in any other path, then yes.
Sorry,
Yeah.
and
So if it's like when you are, it's something like a concept of visiting and visited. So if something you are visiting, you don't want to visit it again because it is already in your path. You don't want to step over. But if you are taking another path, then you want like cell to be used. Like you are going 4 direction.
Mhm.
So if you use right 0, then like the 0 should not be used in the same path again. Like if you start from top and then your right 0 is coming back again, then it should be used.
Hmm. Okay.
So what's the question, like, Sonia, you are asking?
So I'm saying
Uh,
that,
uh, uh,
sorry, no, go ahead.
Go ahead.
Actually, I was
Sorry.
saying, so if it is over here, so it should, for example, my point is right now over here, and it is going to all the 4 directions to check like where the path I should follow. If it is covered by this path, then we'll not be traversing that particular cell because it is already traversed. So we'll be traversing another. So one of the question is, okay, so we are already making them a unmarking it by making it by doing a backtracking. So okay, I was thinking like how if we are already traversed one path, then how if another cell is here, how it would be taking that another path because it's already traversed.
Yeah, so we go
Because,
down the tree, like let's say from level 1 to level 2 to level 3 to level 4. Okay,
mm-hmm.
we mark them. Then we again come back to the level 3. Okay, and
Yeah, that's the point.
and then
Yeah.
level 2, and then unmark level 3 as like not done, and then go to the other path.
Okay, so at the level 2, we unmarked all the level 3 ones, and
Yeah.
then after at level 2, if we check there is another path which that can follow, it will go to the again follow that path and will go to the level 3,
Yeah.
and then
Because at any level deep, like when we are in the recursion, this DFS
Mhm.
recursion,
Yeah.
at any level deep, like let's say you start from first to level 4,
Mm-hmm.
at any place in the recursion, we have to explore all the 4 options. Okay, like
Yes.
all the 4 neighbors.
Mm-hmm.
Okay, so we choose like maybe left neighbor, try to see if that leads us to the answer. Okay, if not, like we will backtrack uh, to that point. Okay, take this case like which you have highlighted. Let's say like you start with 1, go
Mm-hmm.
one right, and then 1 down. So the one which
Mm-hmm.
is highlighted in this example.
Yeah.
Okay, and then from this 0, we will start going to the left. Okay,
Yeah.
and go all the way down, then right, and then up. Okay,
Yeah.
and then
And then
right, and then 2.
down.
So we found one answer. Okay,
Yes.
now we will backtrack, and while we are backtracking, we will mark all of these zeros as
Mm-hmm.
unvisited again. Okay,
Yeah. Till
and
over
then
here.
we are done with this path, and
Yeah.
then we will choose the, let's say, bottom one.
Okay.
Okay, okay, bottom one, and then we will again do the um, DFS. So
Mhm.
but we will not find an answer because we will not cover all the zeros. Okay,
Yeah. Will not be covered.
then we will again backtrack and then go to the right. Okay,
Yeah. over here.
and then again explore. So that's how like backtracking will work. While we are again coming back, we will unmark all those.
Yeah, got it. Thank you. Yeah, so anyone has any problem on this approach and has any problem of understanding this question? And anyone wants to discuss any other approach?
So BFS could not work here, right?
Yes, it's like BFS.
yeah.
I don't think like it will work because BFS explore all the children. BFS is well suited for if we have to find the shortest path. But in this case, I don't think like BFS will work.
Or what if it is told like we have to not visit all the zeros? Like I'm just thinking about now variations.
Like visit all the zeros. What's your question?
Like we don't have to visit all the
zeros.
cells, like all this. Then still it would be same.
I think then also normal DFS would work. We don't require doing the backtracking at that point.
No, we still might have to do backtracking.
Yeah.
We don't want to revisit the same cell. Or might be we want to visit it.
Yeah, I believe like in that case we can follow like a different approach, and I'm not sure like need to try it out. So let's say like we start with first one, okay, and then like for each cell we will see how many ways like we can reach that cell.
Yes.
Okay. So in case of the cell 0, which is on the right of 1, there is only like one way we can reach there. Okay. Okay, the 0 which is at the bottom of 1, there is only one way we can reach there. Okay. Now the 0 which is to the diagonal of 1, okay, we can reach it by sum of number of ways we can reach to the left or reach to the top. Okay.
Agree. But if I have to go 4 directions.
Yeah, but here there are 4 directions. Yeah. So it may mess the things up.
Yeah, then I think this is as good as like a unique paths 1 and 2 problem. But here I have to go 4 directions. Then can I still directly use DFS and get the answer?
So how about if we are moving like for that particular path, we are moving over here and then we are moving down, then going again this right and then going then directly to like this particular 1 down 0, then extreme right, then down 2. That's one path to reach 2. Then this right, then down, and then over here down and then right. So there can be multiple ways because it is not required to cover all the zeros. Then there are multiple ways we can reach.
Maybe like one of the way is just at every instance do the DFS, the exactly same solution that we discussed before.
Yeah.
Yeah, we have to add an additional constraint that we have covered all the zeros. Okay, but in this case, like we will remove that constraint.
Okay, but backtracking still we have to do.
Yeah, it's still backtracking and then like explore in how many ways like maybe we can go there.
Let's see.
Speaking of backtracking, we can take an external array and store how many paths we like the normal DP or something dynamic programming question, like how many paths we can reach that particular destination.
No, but here there are 4 directions. I don't know how we'll put that in DP.
Because if there are only 2 directions, that's a right and down, then you are guaranteed like if you reach the diagonal 0, which is diagonal of 1, okay, you have already covered the one at the top right of 1 and one at the like bottom of 1. You have already covered those. So you are like sweeping that whole array horizontally and then vertically. First row, second row, third row. Okay. So by the time like you are at any index, you are guaranteed that you have covered the index which are on the top and all the elements which are on the left. Okay, so you are building on the previous answer. But here, as Asim is saying, you can also, you may also want to include the answer which is at below you. Okay, so I'm not sure like if that approach will work here.
No, but let's say, so in the same scenario, if I use BFS now, I go 4 directions, make them like that is one path. They explore their children, they explore their children. Don't know if that will work or not.
We can give it a try, and like I need to like leave for the office, so I'm like dropping right
Okay.
now. But
Sure.
keep discussing and like maybe post it on the Slack too, so maybe we can continue the discussion.
Sure.
Thank you, Sonia.
Okay, thank you so much, Gaurav. Seems like no one else has a problem, so let's stop sharing. So anyone who wants to discuss anything else? Okay.
You can
Anyhow,
stop recording.
sorry?
You can stop the recording.
Oh yeah, I'll stop the recording.